Okay, these are the notes for 4.5. So now we're going to take what we've done with systems of equations and we're going to use them into story problems. So my first suggestion with the story problems is make sure you're reading it all the way through first. So if we look at number 1, America's consumption of red meat has decreased most years since 2005, while consumption of poultry has also decreased by a much smaller amount. The function y equals negative 2.03x plus 119.05 approximates the annual pounds of red meat consumed per capita, where x is the number of years since 2005. This function approximates the annual pounds of poultry consumed per capita, where x is the same thing. Based on these trends, predict the year when the annual consumption of red meat and poultry is equal. So we have two functions, y equals negative 2.03x plus 119.05, and y equals negative 0.41 plus 103.21, and each one represents the decrease of eating the red meat or the poultry. So notice these are two linear equations. Whoops, they both have an x and a y, and what do we want to know? We want to know when will the consumption of red meat and poultry be equal. So we want to know when are these two equations equal? Where do they intersect? So basically what we're doing is we're solving a system. So since both of them are already solved for y, why don't we go ahead and let's use substitution. So since the top one is solved for y, let's go into the bottom one, and wherever we see a y, we're going to replace it with negative 2.03x plus 119.05. So that's that y, so now that's going to be equal to negative 0.41x plus 103.21. So it also makes sense because if both of these expressions are equal to y, then they both must be equal to one another. So now let's go ahead and let's solve. So let's add 0.41x to both sides. I need a calculator here. So I'm going to do minus 0.41. It should be 0.41. So you're going to get negative 1.62x plus 119.05 is equal to 103.21. So now let's subtract 119.05 from both sides, and we'll end up with negative 1.62x is equal to I'm going to try that again. 119.05 minus 103. There we go. So I'm getting negative 15.84. And then the last thing that we would do is we would divide that by 1.62. So 15.84 divided by 1.62. And I get approximately 9.8. I rounded. Okay, so now what does that mean? Well, remember your x. What does your x represent? It's the number of years since 2005. So it's going to be, so what is the question? Predict the year when the annual consumption is equal. Well, 9 years from 2005 would be 2014, but then it's in that year, the 0.8, so my prediction, obviously this is an older story problem, would be that it would happen in 2015. All right, so that was basically just taking the functions and setting them equal to one another. All right, here we go. Let's do the next one. Find two numbers whose sum is 37 and whose difference is 21. Well, we have two numbers, so let's let x equal the first number, and let's let y equal the second number. So we have two variables, we need two equations. So what do we know about those two numbers? Well, we know when you add them together, you get 37. And when you subtract them, excuse me, you get 21. So there's my system. Notice to solve this, it's beautifully set up for addition method, because if I add them, the y's are going to disappear. So I'll get 2x is equal to 58. And if I divide both sides by 2, I'm going to get x is equal to 29, which means my first number is 29. I'm going to go back up into here to find my second number, because it says find both of them. So 29 plus y equals 37. And if I subtract 29 from both sides, I'm going to get 8. So the two numbers are 29, oops, that's a 28, 29 and 8. So the math was a little bit easier for that one. So for each of these, you're going to be setting up two equations to solve. Okay, well, this one looks similar. It says the difference of two numbers is 8. The larger number is 3 more than twice the second number. And then for some reason I've typed find the numbers twice. We only have to do it once. So just like with the previous section, x is going to be the first number, and let's let y be the second number. So I need two equations. So the first equation looks like the difference is 8. So x minus y equals 8, which means that x is the larger number because of the way I've written that. Does everybody see that? X has to be the larger one because when I subtract y, I end up with a positive 8. So now it says the larger number is, that's where my equals goes, 3 more than, so 3 plus twice the second number, 2y. So the larger is 3 more than twice the other number. So there I go. I have set up my system. Now it's time to solve the system. Well, this one is solved for x, so I may as well go ahead and use substitution. So I'm going to go up into here, and wherever I see an x, I'm going to replace it with 3 plus 2y. So I'm just using those methods that we've learned. So that means 3 plus 1y is equal to 8. So y is equal to 5. It says to find both numbers, so I'm going to go back up into here and plug in my y. So x equals 3 plus 2 times 5, which is 15. So find the numbers. The numbers are, what were they again? 15 and, oh, no, 13. I was going to say that doesn't make sense because 2 times 5 is 10 plus 3 is 13. I was going to say that's not working out. My fault. Are 13 and 5. Hopefully you guys caught that before I did. All right. Well, let's go to this example. This one looks a little more complicated because we're not talking about just two numbers. So a purchaser for an office supply store bought 12 reams of paper and 8 boxes of writing tablets for $236. He later bought 9 reams of paper and 10 boxes of tablets for $205. What are we looking for? Find the price for 1 ream of paper and a box of writing tablets. So let's use our variables. Let's say x equals the price of 1 ream of paper. So we're defining our variables, and let y equal the price of 1 box of tablets. Okay, so we have our 2 variables. Now we have to come up with 2 equations. Well, he had 2 different trips. So in the first trip, he bought 12 reams of paper and 8 boxes of tablets, and he spent $236. So there's one equation. His next trip, he bought 9 reams of paper and 10 boxes of tablets for a total of $205. So there's our system of equations. So why don't we go ahead? Let's use elimination here. I'm going to eliminate the y's. I'm going to have to use a calculator no matter what I do. Actually, you know what? I'm going to eliminate the x's. I changed my mind because I can make them 36's. I'm going to multiply the top by 3. That makes us a positive 36. And I'm going to multiply the bottom by negative 4. That makes this a negative 36. So when I add them, they'll drop out. So here we go. We get 36x plus 24y equals 236 times 3 is 708. Doing the second equation, we get negative 36x minus 40y equals, I think I know what that is, but I'm just going to go ahead and make sure. So it's negative 820. So now if I add, the x's are going to drop out. I think that's negative 16, but I'm going to make sure because I don't want to make a stupid mistake. Yep. Negative 16y equals negative 112. And if I divide that out, I get 7. So I just found out that y equals 7. And remember, y stood for the price of a box of tablets. So now I need to go plug that in. I'm going to go up into this one, I guess, and plug in my y. So that means 9x plus 10 times 7 is equal to 205. So 9x plus 70 equals 205. If I subtract 70, 9x equals, let's do this, 205 minus 70. That's 135. And if I divide that by 9, I'm going to get 15. So that would be the cost of a 12 reams of paper, or of a ream of paper. So let's see, what is the question answer? Find the price of 1 ream of paper. Well, we know that that's 15. And 1 box of writing tablets. So the ream of paper is $15. And the box of tablets is $7. And there you go. Okay, 2 more problems we have here. All right, so admittedly, this is not a full-blown story problem here, but it does give you an idea that you're going to need as you do some of the distance problems in your homework. So it says a motorboat travels 22 miles an hour with the current and 8 miles an hour against the current. Find the speed of the boat in still water and the speed of the current. So let's say that B is the speed of the boat, and let's say C is the speed of the current. So we need to find both of those. So again, we need two equations. Well, it says that he travels 22 miles an hour with the current. So picture the boat going with the current. With the current means it's going downstream, so it's going faster. So what that means is the speed of the boat plus the speed of the current is going to equal 22. Now, he's coming back and he's going against the current. The current then slows the boat down, and he's going very much slower at 8 miles an hour, which means it's the speed of the boat minus the speed of the current. And that is going to be equal to 8. So there's my two equations. Let's solve by addition. The c's are going to drop out. So 2b equals 30. B is equal to 15. Plugging it back up into either one, I'm going to go to the top. 15 plus c equals 22. And if I subtract 15, my c is going to be 7. So what did I just find? I found B was the speed of the boat if there were no current at all in still water, and the current is going at 7 miles an hour. So it says, find the speed of the boat and the speed of the current. So the boat goes at 15 miles per hour, and the current is traveling at 7 miles per hour. Okay, so the big thing that you have to remember, and you'll have to use this for distance problems possibly in your homework, is if you're talking about going with the current, and it also works with an airplane if it's going with the wind or against the wind. If it's going with the wind, you add the two rates or speeds, and if it's going against the wind or the current, you subtract that rate of the wind or the current from the speed in still air or still water. All right, last but not least, let's read this through. So you have a manufacturing company that spent $3,000 buying new equipment to offer new personalized stationery. The cost of producing a package of personalized stationery is $3, so that's the cost that it costs them to produce it, but they sell it for $3.50. Find the number of packages that must be sold for the company to break even. So they're even telling us how we're going to define our variable. And we're only using one variable in this problem, by the way. So let x equal the number of packages sold, and consider when the amount of money spent equals the amount of money made. So break even in this case would be when they make a total of $3,000, because that's how much they spent to buy this piece of equipment. Well, let's see. They sell each stationery for $3.50. It costs them $3 to make. So does it make sense that their profit, or how much they actually make, would be 50 cents per stationery? So that's how much they are making. So another way to think about it is we want to know at one point is their profit of 50 cents for every X, which is each package. When is that equal to the $3,000 that they put out? So they spent $3,000. They make 50 cents for every package X. Our X stands for the number of packages. So if I just solve this equation by dividing by 0.50, I'm going to get 6,000. What does that mean? That means that they must sell 6,000 packages of stationery to break even. In other words, every package of stationery they sell after the 6,000, that's when they're going to start making their profit. And there's the end of chapter 4.